All right, so wire bonding. Let's go back to the previous slide. I want to show you these legs here, and I kind of want to just break what's inside this package. So the package is this black box. I said that this layout was inside the chip. So if I were to take this layout right here and put it onto this chip, it's going to look something like this. It's going to be down inside of here, probably a lot smaller than the package, because what actually has to happen, so this is my chip. Let's say this is my chip that's inside my package. All right. And each one of these legs comes up in here and connects to some kind of a pad, like some metallic pad. And that goes all the way around the chip. So there's these pads going around the entire chip. This is all inside the black box, right? And so what needs to happen now is I've got all these metal legs out here, right? And I have all these pads on my chip that I showed, right? I'm talking about these pads now, the ones that we looked at. And I need a way to connect each one down to these legs. And so what actually happens is, I don't think anyone does this manually anymore, but they used to. I'm sure that there's a machine that does it. Let me grab like a yellow or something like this. There is actually a machine that takes gold wire and connects from the pad on the chip out to the pad on each leg of the package, just like this. Literally just like this. Wiring them and then stamping them to the pads. And then if I were to go this way, it would be the same thing going this way. Just like that. And so when you look, if you were to break open the inside of a chip, this is exactly what you would see. You'd see the chip on the inside, and then you'd see the wire bonds, these gold wires bonded out to the package, which goes down to the legs, just like this. So this one would be here, this one would be here. And that is how you get signals on and off of a chip. And so on the next slide, that's exactly what I'm showing. I actually wire bonded chips by hand at UNLV when I was doing research with Dr. Baker. Let me zoom in on this one here. You can see the individual pads kind of on this chip right here, right? And they go around. This particular chip only had two sides. This side and this side don't have pads. And then the package, you can see this is all metal. It goes right down to the PCB, just like this. Right? All of these legs are associated with some leg that goes into the board. And then you can see here that they get routed out into the PCB, just like that. You can see where the signals are actually going on this PCB, right? And so what I need to do then when I'm, the wire bonder, you can see the gold wires here. There's one here. There's one here. Is I actually have to sit there with this thing right here. Is called the wedge. And it's got gold wire sticking out of the bottom. And I go down and I click a button on a mouse. This thing's controlled by a mouse. And I make a little stamp. And it's going to stamp some gold wire right here. And then I'm going to move the mouse and it'll move the wire over. And then I finish and stamp it here, and then it breaks it off. And then I go and do the next one. So let's say the next one was this one. I do the same thing. I come back over here, stamp, move it, and connect. And then stamp, move it, and connect. And that is how wire bonding is done. And you can see over here on the right, I have a finished chip that was wire bonded out to this package. And wire bonding is honestly a lot of fun. I really like doing it. It does definitely take some skill. It's very frustrating when you're first learning, but it's an awesome thing to be able to say that I was able to do. And again, you can see the bonds, and each one of these little squares on the package is associated with one of the legs on the outside that are then routed out into your circuit board. And so that's how wire bonding works. I think that it's really awesome. I'm glad I got to talk about this in the next video. I guess I don't need to switch videos. I can just show you these are different package types. So some chips have much fewer legs. You can see that this one only has 8. 4 on this side and 4 on this side. It's kind of like a top view and a bottom view of each of these packages. This package has 16 pins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then it's got like a ground pad on the bottom where you would just connect that to the ground of your PCB. This is a SOIC 20 pins, so there's 10 here and 10 on the back side. All the same thing going on, right? There's a chip inside here. Wire bonds are going out to the pads and so on. Same thing in here. There's a chip here. Wire bonds are going out to the pads and so on. And the same is here. Wire bonds. And that's all what's going on inside of the black box. Okay, so this is really awesome information. Very valuable, really gives you a lot of insight to what's going on, because I remember just getting these black chips handed to me in labs and having no idea how they could possibly perform the function that they were performing. This is how. It's all because of integrated circuits. On this little chip inside of here, there is a whole bunch of components at the microscopic level that are behaving exactly like the resistors and capacitors and transistors and diodes do at the full scale, but at the microscopic scale, and they're doing the exact same things, okay? I'm going to go ahead and end this video here, and in the next video, I'm going to show footprints, and then I'm going to start talking about printed circuit boards. Those two concepts are related to the package types, okay? So I'm going to end this video.